Hi, I'm Richard Venditti, and today we're going to be taking a tour of a paper recycling mill. We're here in West Virginia at the Resolute Forest Products Paper Recycling Mill, and we'll have a tour with Daryl Pogue, who will walk us through the mill.
Good morning. Thank you, Rich, and welcome to the Fairmont Pulp Mill. Glad to have you here today. What we do here is take recoverable, recyclable papers and clean it, bleach it, and turn it into a recycled bleach craft pulp for paper makers to make their products out of, and otherwise also known as a market Deinked Pulp. So, welcome.
Okay, great. All right, so why don't we get started with the first part of the process. We'll start to look at the incoming paper as it's being delivered here and stored. We know that paper is made out of really basically two different types of fibers, mechanical fibers that are mechanically pulped and chemical fibers that have been chemically pulped and bleached. Is this important to your process?
Oh, it sure is, Rich. In fact, the brightnesses that we have to achieve, we're typically looking for mostly chemical pulp.
Okay.
So as the waste paper comes in, our material handlers grade at the dock, and one of the tests we do is spraying a fluoroglucinol to help look for and show us how much mechanical fiber might be in the waste paper. So let's step over and look at Shane and watch Shane as he tests for this mechanical pulp.
Okay, sounds good.
So fluoroglucinol is a somewhat corrosive. So Shane has his proper PPE on for spraying this product, but he's looking for a color change. If that would have been mechanical pulp, that would have turned red and possibly even a deep purple if it had enough mechanical in it. As it is, what we're looking at right now, we know for sure that this is a good chemical pulped paper. This particular paper is a pre-consumer grade, but to us, what's also important is we're saving this paper from having to go to a landfill by being able to use this. It is a small percentage, but it is a pre-consumer grade. If you will notice, though, all the foil-looking material on it, as well as there will be some poly up in this. Our process, by our special pulper that we have, our drum pulper, easily removes these contaminants, whereas traditional batch pulping, this would be too much trash for the detrashers.
Okay, now we're at the first part of the process where we have the inventory of the paper. Pretty important process where we're storing the paper. Daryl, can you tell us a little bit about where you get your paper from and kind of the purchases that you make to feed your system?
Sure, Rich. Yeah, our waste paper or recoverable paper can come from anywhere east of the Mississippi. We extend up into Canada, a huge portion up into the Northeast, the major cities, Philadelphia, New York City, out of New Jersey, all the way down the East Coast into the Southeast. So it really comes from everywhere.
Okay, and what kind of papers do you purchase?
Biggest majority of what we're purchasing is sorted office paper, or also known as sorted office waste. Basically, it can be any paper that might come out of your office drawers or a file cabinet that gets dumped. It comes in both shredded and also whole loose paper. So
these storehouses hold a lot of paper. About how long can your mill run on what you have in your warehouse?
If our warehouses were completely full, we're probably good for only about 4 or 5 days. Wow. This is a very large mill.
This mill is pretty special. It actually accepts very difficult to recycle paper products. Can you tell me what those are?
Some of these papers are things like orange juice boxes, milk cartons, aseptic packaging. These are all containers or papers that were treated to hold liquids. So therefore, by just going in our process to begin with, the difficult to repulp, reslush. So with the correct chemistry, enough time and energy going into the fibers, we can defiber those and reuse those as a beneficial stream as well.
For your process, we know you need water. How do you get the water and how do you treat it before it comes into your process?
Rich, we pull water straight in from the surface of the Monongahela River. The Monongahela River is formed right here in Fairmont. Actually becomes one of the only a couple rivers in the world that flows north and is navigable. But we take that surface water, and it's too dirty for our process, so we have to clean it. So we're standing on top of our the river water clarifier. We add chemistry. We add both a coagulant and a flocculant to bring the particulates together, and then we settle that out to get a much cleaner water to use. Then that water passes through a sand filter media system. There again, it's just, it's a separation. If something's too big to go through that fine sand media, it's rejected. And typically what we see there is mud. And then our final product of the fresh water then is a very clean water, like less than 1 NTU. So looks like drinking water, but it's not potable. We don't treat it for that, but it's very clean water then for our process.
Okay, Daryl, we talked about your mill being able to receive very difficult to recycle material. Can you just describe to us what we got here?
Right, see, we have like orange juice boxes, and again, our process will have enough time and temperature and chemical concentration to go in and break these wet strength bonds down to be able to reuse this paper again.
Okay. So things like mozzarella containers, they're coated with polyethylene and wax. Here's something that has a lot of foil. It's got a lot of good fiber in it. It's got this plastic window. And then for marketing purposes, they like foil. So there's a foil on it that doesn't have the fibers, but the fibers actually are inside there, and there's quite a bit of fibers. Oh wow. If I try to rip it, it's very difficult to rip because it's got some kind of polymer coating on the outside. But look at all that good fiber in the inside there. If we can liberate that fiber, there's no ink there. Good fibers for making new printing and writing grade materials or anything.
We'll remove all of that in our process.
Okay, that's great. So you have a separate batch pulper to do this, and all the other remaining material goes through a more conventional pulper, a more gentler pulper.
Exactly, yes.
Okay, interesting. And this is good fiber in here. It's just how do you get to it? How do you separate it from all this plastic and foil and things like that?
We have to take the contaminants off because our customers are only going to want the fiber that's inside, of course, yes.
Daryl, can you walk us through the process before pulping?
Sure, Rich. What happens, our pulper operator here will take a bale of waste paper, place it on the conveyor. It's the whole bale. What we have here is a dewiring device, so it automatically takes the wires from the bale. That way it keeps our operators safer. They're not cutting wires or being exposed to that hazard. And then the wire wolf will then drop the paper onto the floor, and he shoves it into the pit. And from there, the conveyors are all level controlled and everything, but we've calibrated that to know how much weight we're going to put into this pulper. And then what's inside this pulper? It's a high consistency pulper.
Yes.
We do use water and a little bit of sodium hydroxide to help break down those wet strength properties.
Okay.
It uses a helical rotor inside, and again, it's a batch pulper, so it's going to be in here for somewhere around an hour, which that's all controllable. Okay. But probably somewhere around an hour, it's going to be mixing and breaking down those fibers.
Okay, so at the end of the pulping, after you've defiberized as much as you need to, it's high consistency pulp, so it's pretty hard to pump. How do you get it out of the pulper?
So at the end of its mixing cycle, then we add more water to the pulper, bring that up to a level, and then the pulper is dumped at a much lower consistency. That's much easier for the pumps to pump. And from there, then it's stored in our accepts tank, and then it's metered into the process from that point.
Okay, so Daryl, what do we have behind us right now?
What we have behind us right now, Rich, is a conveyor that's feeding the pulpers. So we've taken our waste paper, we've removed the wires automatically, and the conveyor's actually going up this incline to go up to the pulpers. We are measuring it. We're measuring it with a nuclear device that basically is looking at the density of the paper. And from that device, we've calibrated that based upon whatever density it is. We convert that into a weight or how many tons they want to feed. So the conveyor will speed up and slow down to meet that set point that the operator upstairs asked for the amount of paper coming into the pulper.
So for your pulper to operate correctly, you have to have a certain tons per hour, let's say, fed in.
Exactly.
And that sensoring device is going to allow you to measure that and either increase or decrease the speed of your conveyor.
Along with, and the DCS then will calculate how much water, to add with this paper, so we have the proper consistency when we're repulping.
Okay. We're in front of your drum pulper now. That's the conventional pulper for most of your material. Can you walk us through how that drum pulper works?
Yeah, Rich. What's happening, the conveyors that we saw earlier are confluencing together, based upon what the DCS is calling for weight. The paper is then dumped into an open end of the drum pulper along with water. Our recipe calls for a certain consistency. It is high consistency pulping that we do. And at that point then the paper and there are baffles and everything inside the drum. The paper and the water together are lifted at about like a 10 or 11 o'clock position, and then it falls. And that constant, as the drum is rotating, and the falling of that paper and water together reslushes or defibers the waste paper. It's very gentle compared to conventional batch pulpers. This way we try to keep our contaminants that come in, our wood, our pop cans, banana peels, whatever comes in, we try to keep them as large as we possibly can with this gentle pulping. At the end of the pulper, we have a screening section where the high consistency pulp is now hit with more water. That helps to wash the paper fibers off of the contaminants. The paper fibers fall through those perforations, become accepts, and then our rejects come out in those nice large pieces at the very end of the drum.
So after the pulp comes out of the pulper, we go straight to the high density cleaners. Can you tell me about how the high density cleaners work?
Yeah, what we have is the high density cleaners are going to go after separating materials by weight or by its density. So what's happening is the material is fed into the cleaner tangentially. It's set up in a rotating motion, and by centrifugal force, all the heavies, or the heavier the material, the farther it goes out to the center. It is out on the outside wall. It's dropping, and then by that ends up down in a grit pot, which under timers dumps the rejects, and by a differential pressure, the stuff in the center, which is the accepts, there's a vortex finder in the top that the pulp comes out the top and is accepted that way by differential pressure.
After the pulp is cleaned with the high density cleaners to remove the big staples and glass and things like that, it comes to the screening operations. Can you tell us a little bit about the screening operations?
Sure, Rich. What we have in screening is actually now we're going to create a barrier. In other words, unless the contaminant is small enough to be able to pass through these slots, then it's going to become a reject. So what barrier screening, and we use pressure screens, what that's doing is going after contaminants by shape and size. We utilize slotted screening in both our coarse screens and our fine screening. And if you look and see, again, unless something is small enough to get through those slots, it's going to become a reject. It cannot pass through. This is a barrier.
Okay, so the concept is that the fibers go through the slots and the large contaminants are blocked by the slots and they go out a rejects port.
Exactly.
Okay. You have coarse screens followed by fine screens, is that correct?
Exactly, yep.
Can you tell me what the difference is between coarse screening and fine screening?
Sure, yeah. The coarse screening is going after rubber bands and plastics and stuff like that. Fine screening is, again, probably like 25% of the width of what a coarse screen slot is. And the main contaminant we're going after at that point then is stickies. Stickies in our industry, coming from bindings, Post-it notes, self-adhesives, but the stickies is what we're primarily looking at in the fine screening section, and that's the heart of the removal of stickies in the mill.
Okay, Daryl, we're at the forward cleaning section now. Can you explain to us about what's around here?
Sure, Rich. Again, forward cleaners are just smaller versions of high density cleaners. So again, we're going to go after things of more weight than fiber or water. Behind me, is our stage of primary cleaners. We have 96 of these cleaners. And again, it's doing the same action as high density, so a lot of centrifugal action. What's special about our primaries are inside of each of these bodies are 3 small cleaners inside. And then as we're coming down the middle, also in my primary and my secondaries, we're also adding re-energizing water to help thin out the rejects, but it's also re-energizing that centrifugal force to keep the fibers in the center and the rejects out to the end. So I have my primaries, which have a higher reject rate. Again, I want to get the pulp in, get it out, get passing on and through the process. And then over here in my secondary stage, I begin reclaiming some of those fibers. So the reject ratio in these is not as high as what we have in the primaries behind us. So the primaries and the secondaries are the same model type of cleaner, but my tertiaries and quaternaries are different. Let's go take a look at those. What we have here, Rich, now is our tertiary stage of forward cleaning. Now this type of cleaner is only one cleaner, so it's a little bit bigger on the inside. Still the same thing though, we're still centrifugal action. The reject rate from this one is again lower than we had at the secondary. A little bit special about our tertiary, the lower reject tip here is transparent, so we can see whether or not we're having any plugging actions. And then finally, we have our quaternary stage. Our quaternary stage is our last stage. They're the exact same as the tertiaries, minus the transparent tip. But this tip, because the rejects are so concentrated, it's a porcelain material down there, because otherwise the wear rate would be so high that we'd never be able to keep up with replacing the lower reject tips of these cleaners. So again, they're a porcelain material. And then that's our final stage. Rejects from there leave the mill, and the accepts from each one of these goes back, feeding the subsequent stage in front of it. So my access from our quaternary go back to the tertiary go back to the secondary back to primary, and if it's good enough, becomes an accept from there. After forward cleaner accepts, we're coming near the end of our first stage water loop. We're going to do that now by washing the pulp. So the accepts from forward cleaners come to a pair of gravity decker drums. And the pulp is both sprayed and is underneath these drums, has to go through a rotating drum, and this action of removing the water is a washing action. So small ink particulates and fillers and everything go with the water, and we have the pulp then being accepted into a stock chest for our next dewatering section.
After the gravity decker, what happens next?
Next, the pulp is then pumped up to our twin wire presses. Somewhere around the consistency of 4% probably is at the head box. And as we go subsequent, there's a gravity drainage zone, and then a wedge zone, with gradual increased pressure from these two fabrics. And then we go through a nip section, a pressing section. So finally, our final discharge consistency, as you can see, is very heavy. This is probably somewhere between 35 and 40% fibers. There's no water left in it. And this is preparing the pulp then for the kneading section next.
Can you explain to us what the kneader does and why you use it?
Sure. The function of the kneader is to take the pulp, and as it sounds, it's a whole lot of, it's fiber to fiber action. So the job, what it's trying to do is that fiber to fiber is rubbing into the pulp, is rubbing against itself. It's to detach ink particles from the pulp paper fibers. And then, of course, following the kneaders right away then is going to be our first stage flotation, where we're going to remove the ink from the slurry.
Okay, so the kneader actually rubs those ink particles off the fibers, yes, and then that prepares it so that the flotation de-inking process is more efficient.
Exactly.
Excellent. What are the conditions in the kneader?
A lot of horsepower. The action itself adds heat to the fiber, so it's dispersing, but we have to take care not to add too much power, because we can also create fines. All right, Rich, what we're looking at here is a worn kneader screw, but looking at the kneaders upstairs, wasn't a whole lot to see. Well, this is what's inside. There's actually 2 of these shafts. They're high speed The flights here actually take the pulp from the throat, feed it into these, feed it into this star section. These never touch, but it's very close tolerances. And again, that's what's making that pulp rub against itself, and then it's discharged down this end.
Okay. So now we're at the flotation de-inking cells. Can you explain to us how those are working?
Sure. So after our kneading stage, we have ink detachment from the fibers, hopefully. At that point now, we're going to add lots of water and lots of air to the pulp. We're doing that through mixing. As the pulp is pulled in, we add air through this venturi, which is drawing the air into the pulp, and then it enters the vat. And as it's in the vat, it's sized so that as the air bubbles climb through the slurry of pulp, ink particles are attaching to the air bubbles and are then removed as a reject. Accepts are somewhere near the middle of the bottom. As with several other stages in our plant, the reject rates on primaries are higher, but then we have our secondary stages that are coming back in. Reject rates are much lower, so we have fiber recovery, but still getting rid of the bad contaminant, the ink particles that we want to get rid of. What we're going to do with the dispersion is, again, close tolerances, but what we're going after is we're going to shatter. It's as the pulp goes by the rotating elements, and there's a stationary element, we're going to shatter with lots of steam, lots of heat, a lot of energy, the sticky. So what we're going after, we're preparing the pulp for the second and final stage of flotation. We're trying to make all these particles small enough to where they'll attach themselves to ink bubbles so we can remove them.
So the disperser allows you to break up stickies particles and also ink particles?
Yep, to make them small enough so flotation and final stage washing can remove them from the process. Where we're at now, Rich, is the disc filter. So it's the final stage of washing. This is accepts from the second stage flotation, and so final washing. We're also thickening, preparing the pulp for storage in the high density tower before we're going to make the final pulp sheet out of it, and also prepping it for the reductive stage of bleaching. As the rotating discs are coming around, there's a drop leg pulling vacuum on the disc, so the pulp is formed on these discs, on the fabric, on bags, and then it's scraped off on the other side, thickened, with the water removed. The water in the middle is going down and going to be going to a DAF.
Okay, so you're basically separating water from fiber in this separation process.
Yes.
So we know in the recycling process it's very important to take out the ink and the stickies and other contaminants. But what about the fiber? What about the color of the fiber and any lignin that happens to be in the fiber?
So we have two bleaching stages in our process. The first one being an oxidative stage. That's going after residual lignins that's left in the pulp, and we're trying to make it whiter and brighter with that. Our second stage is a reductive stage. We can use various chemicals to form a sulfenic acid that's going to go in and break those color bonds and strip the colors from the pulp. Both bleach reactions take place in a bleach reactor, so it's an upflow tube. By going upflow, we're under pressure. No air is present to react with the bleaches, and with time, temperature, and chemical concentration in, that's how we control our bleach stages.
Reusing the water in your process is really important. You can't just be throwing your water away into the river. You have to recirculate it quite a bit. How do you deal with those issues?
Well, you're right. We use a lot of water. So, where we're only pulling 2 to 3 million gallons a day of water out of the river, we're treating over 50 million gallons per day in the mill. So we have our 3 water loops. As we're doing those wash stages, we clarify all of that water using dissolved air flotation clarifiers. The dissolved air flotation clarifiers are a dual chemistry. Again, we're using a coagulant and then a flocculant to bring the particles together. And we have both settling and we have floating. So they are also injected air. We have recirculation of the clean water in the clarifier. We're adding a lot of air under pressure, and as that pressure is released out in the surface of the DAF, that effervescence creates more air bubbles, and we're floating the lightweight contaminants that we can remove off the top, and then of course they become sludge. Okay, after we have sludge from the dabs, Rich, we have to start solidifying that. We're going to get rid of that. It's very watery, as we saw coming off the dabs. So again, we add a little more chemistry. It's a coagulant to bring the particles together. And then we're going to come out over this, watch your step here. We're going to come out over this gravity table to start by gravity only, de-water the sludge. And you can see as we go by, each of these things are breaking up that solid, so it's opening up the flock until down at the end. At the end, we have a material that's now heavy enough. This is heavy enough to be fed to the twin wire presses for final disposal.
And there's a wire with holes, a wire mesh with holes.
Yeah, this is a fabric, and the fabric has to be the fabric's actually holding the particles, the particulate here, and as the fabric's passing under the machine here, it's cleaned and washed always. But then this becomes the feed now to our twin wire presses below. So let's go take a look at those. Now we have the feed that came from the gravity tables go down to another twin wire press. Operates a whole lot like the dispersion presses that we saw at the first stage flotation. So it's two wires coming together. It's a gradual, it's a gravity zone and a modified S-wrap zone. It's putting more and more pressure on the cake. And then we have actual knit pressure presses pressing the cake to where we end up with a final consistency of this short paper fiber cake between like 50-55% consistency. Now this product, Rich, is from our mill is used 100% beneficial reuse. The majority of it goes to land reclamation sites. We're in West Virginia, a lot of coal mines here in the past and present, but it goes back for reclaiming those sites. Our SPF, or short paper fiber, is mixed with soil to help condition the soil so it's able to grow grass, able to grow plant life again and put back to nature that way. We also have, with the Marcellus Shale gas boom that's going on, some of those cuttings and those tailings are too wet for those folks to dispose of. So they're taking our SPF to help solidify, or it's soaking up a lot of that water that they get out of their drilling operations to become a heavier consistency product then that they can get rid of as they do.
Okay, Daryl, can you tell us a little bit about the water that you have to discharge to the river?
Sure, Rich. We have to take the water and clean it, of course, before it goes back to the river. So first, we go to a settling clarifier. Our primary clarifier settles out the solids. Water from that is then discharged into our biomass reactor. The reactor is adding air and nutrients for the biomass. And then water from that is discharged into the secondary clarifier, where we reclaim our biomass, and water from there is clean enough to discharge then back to the river.
All right, now we're at the pulp former. Can you explain the different operations here?
Yeah. Now that we're at the end of the process, so we've taken and we've cleaned, whitened, brightened our pulp. Now we're going to form it into our final product. So the pulp is pumped up into another twin wire press into the head box at around a 3 to 4% consistency. Goes through another gravity zone. Goes through another intermediate S-wrap zone, and then enters the presses to further press it and form a sheet. The discharge off the pulp former is probably going to be somewhere around 40% consistency. Pulp from the pulp former then goes through the heavy duty press, so from 40% consistency to about 50% consistency, Rich. And then the pulp goes freely into the pulp dryer, where it's going to ride on a cushion of hot air. So our boiler creates steam, makes hot air, and that pulp sheet's suspended on that cushion of hot air for 17 passes throughout the dryer, and then to come out on the other end a dry sheet.
And you use this air flow to hold the paper, no steel drums, because you want the pulp to be able to be re-pulped up?
There's no pressing taking place. There are rollers on either end just to help the pulp make the transition. So it's going to go, like I say, 17 decks throughout the entire dryer.
Okay, what's happening next?
Well, we came out of the dryer. We're a nice dry sheet now. Our cutter layboy cuts the pulp sheet into into widths. So we have 6 bales wide, and also has a fly knife cutting it by length. Each of our sheets is about a 33 inch by 33 inch, and from there it's stacked, weighed, and what we're seeing now is this is actual weight that we're going to use for billing and for interstate transport. We are measuring in metric. The bale press is not only flattening and making a much tighter package, it's pressing all that air out, but it also has a plate in there that's measuring the final moisture to where we know how to bill our customers, because the customer won't buy water, they only buy the fiber. We have our pulp bales now that were wrapped, they're packaged. Everything has been assigned a bale number, which is also assigned into lots. Our lots, Rich, are basically the amount of pulp that will fit onto a rail car, so it's around 70 metric tons. If we choose to also ship out on trucks, several customers just take truck shipments, so we'll break that lot down and send it to them over truck. But from all of that, we know forever what that quality was for billing purposes and everything. Those lot numbers, that bale number, and the pulp leaves here, goes to our customers.
Daryl, I want to thank you for hosting us here today. Your mill is very exciting. Lots of interesting things happening here, and doing a lot of good for the environment.
Thank you, Rich, and it was a pleasure having you guys here today. I really enjoyed sharing with you and everything, and you're welcome back anytime, and let us know if we can answer any questions in the future. Thanks again.